So my goal with this particular lab wasn't to challenge you with like tons of the most difficult equipment and measurements. In this lab, I wanted us to get really good at some basic science skills. So I wanted us to get good at things like data tables, graphing, scales. I wanted us to talk about slope and y-intercepts, and probably the trickiest, number 5. Number 5, where it asks for like write the equation of the line in terms of y and x, as well as like the variables in this experiment. So what I figure is this assignment is a learning assignment. It's to help us figure out like all the basic science skills so that when we do lab practicals, which are like test grades that are labs, we're all on the same page. One of the things I'm going to look for when we do like lab practicals in the future is I'm going to be looking for things like how you set up a data table. In this particular example that's on the screen, I put independent on the left, dependent on the right. You'll notice that the units are in the header. So check yours for me right now. Did anyone on theirs put grams next to all their measurements or kilograms on every single box? If you did, go delete those. The reason I'm going to have us leave the units just in the header and not in the body of a table is when you do these graphs later electronically, that'll prevent it from auto-graphing for you. We want the data to graph itself, so leave the units in the header. The one on the board says distance in centimeters and time in seconds. Yours is going to be the mass in grams, kilograms, and weight in newtons. Okay. No units in the body. So go double check that one. For the graphs, I saw you guys were taking your time. It looks really, really strong. When I'm looking for a graph, this one is mass versus volume. When I'm looking for a graph, I'm looking for the independent on the x-axis. So can you guys check? Yours should have mass in kilograms on the x-axis. If you did mass in grams, that's totally fine for now, because we did both. It'll just mean your units are a little funny for slope. On the y-axis was the weight, because the mass is what you changed, that's the x-axis, and that changed the weight, the force of gravity, that was the y-axis. Both axes should be labeled, so go check this for me. Look at your graph. Does it have mass with kilograms in the x and weight in newtons or force of gravity in newtons on the y? Make sure it's got units there. I will totally ask on a test someday to graph data. And one thing I'm going to look for is that your scale is evenly spaced. Your scale is evenly spaced, so you don't go from like 1 unit to 3 units to 4 units. Units that are evenly spaced so that your scale makes sense. And this is a funny one from AP. Graph takes up at least 50% of the available space. We don't want it like scrunched up in the corner. We don't want most of your data to be off the screen. The graph should take up at least 50% of the space. One thing I do every summer is I grade AP tests. It's oh gosh, it's a lot. You grade 1 question, but for like 4,000 tests. And one of the things they do is they do this graph takes up 50% of the space. I saw lots of people have lots of dots and nice straight lines, but then you left out the best fit line. Your graph data looks something like this. Throw in a nice best fit line. Your best fit line should be near the points that are on there. And this is a linear graph, so it's going to be a straight line, doesn't need a curve. So before we go on to like helping on the back page, I want you to help me out. On this next slide, I would mark this person off a point. Anyone see what I would mark this person off for? Nick, what do you want to add? I've got 3 points on the line, but I've got, what, 5 points below the line?
Because they indicate on the y-axis that it would start at
I didn't even realize that, right? The y-axis should start at 0 and they start at 25. We actually can't skip. It has to start 0 on both sides. Right? So actually, I would have to mark those out for 2 points. Their line of best fit isn't near enough to the points. I'd also take off they didn't start at 0. While it doesn't look like it matters because this graph, like it looks pretty, that means later when I go fit a function to this graph, that my equation's gonna come out wrong or not correctly model the world. What would this person get marked off for? Raise your hand when you think you know. It doesn't take up 50% of the graph. It's like all scrunched over here in the corner. Right? And it makes it hard, like then they can fudge data points a little. We want it to take up enough space so we can see it. Okay. All right, what about this one? What would this person get marked off for? Raise your hand when you think you know. Yeah, the scale on the y-axis. All right, we're going from 29 to 38 to 54 to 62. Like, pick a scale and stick with it. I think this person was trying to make a nice linear graph, and so then they just put their dots in a straight line and then put the labels in last. So this person would lose points because their scale is not even. And actually, I would probably also that they don't start from 0. Right? Is that graphs actually will get us equations that relate variables. Those equations are kind of shortcuts for what's going on with physics. And our graph's gonna look something like this. We've got mass in kilograms on the x-axis. We've got weight in newtons on the y-axis. We're gonna put in this nice best fit line. Now the physics part comes. Someone was over there being like, oh, this is like algebra. Yeah, it's like algebra. And the very last step turns it back to physics. So here's how this works. What type of graph is this? I think our choices were like linear, direct, parabolic, inverse. What type of graph is this? Direct. In some tables I like helped you with this. What's the difference between direct and linear? If you haven't seen this one before, this is linear because it's a straight line, but it's also direct because direct means it starts from 0, 0. That one of your data points is the origin. A direct relationship is a straight line that goes through the point 0, 0. So I asked you in your lab, what is the y-intercept? And does that make sense? So what is the y-intercept of this graph? Sydney.
0, 0.
And that would mean 0 mass, 0 weight. Does that data point make sense? You can check if a direct relationship makes sense by figuring out, does 0 on your x-axis and 0 on your y-axis make sense? So to me, I'm like, okay, if there's no mass, then there's no weight to pull down. There's nothing for gravity to pull or act upon. So no mass, no weight, that 0, 0 data point makes sense. What about the slope? Everyone's favorite thing from like algebra. How did you calculate your slope? Oh, sorry, I pointed at both of you at the same time. How about Jamie and then Grace? All right. So you can do this as rise over run. Grace?
Changing y for changing x.
And just for funsies, can someone give me the data points they used for theirs? Nicholas.
I did 0.11 and then 0.22.
All right, so 0.11, 0.22. And so when you go to your slope, it would be 2 minus 1 over 0.2 minus 0.1. And if we keep in the units, that's actually going to help us with the thing. The 2 and the 1 were on the y-axis. Those were measured in newtons. The 0.2 and the 0.1 were on the x-axis. Those were measured in kilograms. So the slope is going to be, what did you end up getting for that slope? Right? So if we keep those numbers anyways, this ends up with 1 over 0.1. This ends up with something like 10 newtons per kilogram. Okay? The slope of this graph actually means something. Any ideas what this 10 means? What this slope means? Ooh, yeah. Okay, that's really close. So this one, 10 kilograms per newton. Wait. So it's actually 10 newtons per kilogram. Right? So this means that on Earth, every 1 kilogram of mass gets 10 newtons of weight. If you move to a different planet, what would you expect? More gravity, more weight. Maybe if you went to Jupiter, it would be like up here. More gravity. What if you went to the moon? What would you get? Less gravity, less weight. All right. So this thing that you guys measured with your slope actually has a special name. This thing is called the gravitational field. You measured the gravitational field of Earth. Its symbol is going to be a little g for gravity. And if you went and did this experiment somewhere else, it would give you different values. So that's kind of cool. You found a new thing. Anyone know what that number is approximately supposed to be?
9.8.
Yeah. So it's about 10. If you measure it super, super carefully,